Let us guess or estimate the value of limit as x approaches 1, x squared minus 1 over x minus 1 using table of values. Now, before we do that, let's just substitute x equals to 1 in the function. When x equals to 1, I get 1 squared, which is 1 minus 1 over 1 minus 1, which is equal to 0 divided by 0. 0 divided by 0 is one of the undeterminate form. One of the undeterminate form. There are some other indefinite forms that you're going to see when you find limits, such as infinity over infinity, infinity minus infinity, 0 times infinity, etc. Now, idea over here is x2 approaches 1 from both sides of 1. Meaning x2 approaches 1 from the values below 1 and from the values above 1. Now, how do we do this? Now, let's say we start point 1 distance away from 1. That means say 1 minus 0.1, that is 0.9. Suppose we start. And 1 plus 0.1, which is 1.1. Now, when x equals to 0.9, when I substitute in the function f of x, I got 1.9. When x equals 1.1, I got 2.1. Now say we get more closer, say 0.01 away from 1. So I get 1 minus 0.01 or 0.99, or 1 plus 0.01, that is 1.01. When x is 0.99, f of x gave me 1.99. When x equals to 1.01, I got 2.01. Now let's get more closer, say 0.001 away from 1. So 1 minus 0.001 or 0.999 or 1 plus 0.001, which is 1.001. Now when x is 0.999, I got f of x is 1.999. When x is 1.001, f of x gave me 2.001. Now, can we guess the limit as x goes to 1 of x squared minus 1 over x minus 1? Now, what you see as x is increasing, x is approaching 1 from the left, f of x is going up from 1.9 to 1.999. Or from the right side, when x approaches 1 from the right side, f of x decreases from 2.1 to 2.001. We can easily guess now f of x is approaching clearly 2 as x approaches 1. Now, let's look at the graph of the function f of x. Is x squared minus 1 over x minus 1. Now in the calculator we go to y equal into the formula, which is x squared minus 1 divided by x minus 1. And then go to window to see whether we have a good window. So window is from x value go from negative 10 to 10. We really don't need that much. We can go negative 5 to 5 because we want limit at 1, right? Limit as x approaches 1. And the y is minimum to maximum is okay. And let's graph it. Here's the graph that we see. Now, this looks like a rational function, but actually what we get is a straight line. Now, why we got that? Because we can actually simplify this function. X minus 1 is a factor of the x squared minus 1. Factors of x squared minus 1 is x minus 1 times x plus 1, a squared minus b squared, and divided by x minus 1. And since x is not equal to 1, that's what we get the limit as x goes to 1. So we can cancel out. That means the function is equal to actually x plus 1 when x is not equal to 1. So that's what we get the straight line, y equal to x plus 1. Now, we got the limit as x goes to 1, x squared minus 1 over x minus 1 as equal to 1, right? So why we got that? Actually, we got 2. Now, when x equals to 1, it was not defined. And now over here, we don't see any hole, but if you trace it, you click on trace, now you can see when x equals to 1, if we actually go to that one, then there will be no y value, but it doesn't go there. But we can go to table here. You go to table set and keep table as here, and then go to table and say when if I put x equals to 1, it has an error, mean that's not defined. Right? So that's the important thing to understand. Guess or estimate the value of limit x goes to 0 sine x over x using table of values. Now again, the idea is x2 approaches 0 from both sides. Now, like earlier, let's start 0.1 distance away from 0. So 0.1 below 0, which is negative 0.1, and 0.1 above 0, which is 0.1. Now, when x equals to negative 0.1, I get, when I use my calculator, I get 0.99833. Now, in your calculator, you can see your sine x. So x is the angle. So make sure we measure angle here in radians. So therefore, in your calculator, you make sure you go to mode and make sure that to set the angle measure to radian. It might sometimes maybe in degrees. So we have to make sure it changes to radian. So when x equals to 0.1, also I get 0.99833. Now let's get more closer to 0. Say 0.01 away. So that means we get a negative 0.01 and 0.01. Now when x equals to negative 0.01, I got 0.99998. Also, when x equal to 0.01, I got the same number, 0.99998. Now if we get more closer, say 0.001 away from 0, that means 0.001 below 0 or negative 0.001 0, 0, 1. In my calculator gave me 1. And when 0.001 also I got 1. Now it's very clear, as x approaches 0 from both sides, f of x or sine x of x is approaching 1. Therefore, limit x approaches 0, sine x of x is equal to 1. Now let's look at the graph of sine x of x. Here we go to y equal, enter the formula sine x over x, and go to window. Now we don't need a big x value, say -5 to 1 is okay, and minimum y we don't need that much, say 2 to 2, because sine x take only values up to 1. And let's graph it. See, this is the graph we see here. Now we got here the limit x goes to 0, sine x over x is equal to 1, meaning as x approaches 0 we get 1 over here. As you can clearly see, it approaches 1, but in fact in this graph there should be a hole over here. Again, we don't see that. If we go to trace and at x equal to 0, see there's no y value, mean that's not defined at x equal to 0. Now if you go more little bit, when x other values, there are y values. Also, if you go to table, if you put x equal to 0, you're going to see that is an error.